Hello everybody and welcome back to a brand new video, and in this video I will explain problem Qpwoeirut, whatever his name is, and the city. This is basically problem C from round 809, that was a Div2. Yeah, so let's get started and see how to solve this. So in the problem we have been given a city which has n buildings and where n is around 10 to the power 5. And we have been given the height of each building as an array. So we know h1, h2, h3, so on up to hn, right? So these are the heights of all buildings. We call a tall building, we call a building I tall if height of building I is more than the right neighbor and height of building I is also more than the left neighbor, right? So if a building I follows the following condition, that is its height is more than its left and right neighbor, then the building I is tall. We can add some height to the buildings, right? We can add some height to the buildings and we want to maximize the number of buildings that are tall. So we want to add the minimum amount of height. We want to add the minimum amount of height to get maximum amount of tall buildings. So that's the problem. So how can we solve this? First of all, I will break the problem into two subparts. The first subpart where the number of buildings are odd, and the second subpart where number of buildings is even. You will see why I'm doing this later. So I will break into two subparts. So the subpart one is when number of buildings is equal to odd. So that is n is equal to odd. So when we solve the case n is equal to odd, we will first try to find the maximum number of buildings that we can have. So first of all, we will try to find the maximum amount of buildings that we can have, and from that we will try to find the minimum number of height that we need to add, right? So first of all, we will find maximum amount of buildings, and then we will find the minimum amount of height that we want to add. So first we have n equal to odd, right? So it will be something like this: a1, not a1, let's call this h1, h2, h3, h4, h5. So first of all, we want to find the maximum amount of buildings, tall buildings, that we can form. Obviously h1 has no left neighbor, so h1 cannot be tall. Similarly, h5 has no right neighbor, so it cannot be tall. So our h1 can be tall, right? Our h3 cannot be tall because no two adjacent buildings can be tall, right? So our h3 also cannot be tall, and our h4 can be tall, right? So we have two buildings, h2 and h4, that can be tall, right? So the maximum amount of buildings that can be tall for length n is n by 2. So at the maximum amount of buildings that can be tall is n by 2. So now we know that if our n is equal to odd, the maximum amount of buildings that can be tall is n by 2. So now we want to find the minimum amount of height that we need to add to make n by 2 buildings tall, right? So now we want to find minimum amount of height to make n by 2 buildings tall, right? So here we have seen only one configuration, right, where h2 and h4 can be tall. Can there be any more configurations where we can make two buildings tall? What I mean is, can we choose any two buildings that are not h2 and h4? That is there any more configuration? So if you try to form any more configurations, that is h1, h2, h3, h4, h5, our h1 and h5 cannot be tall. We chose h2 in the last configuration, so we will not choose h2 anymore. So now we will choose, let's say, h3, right? But if you choose h3, you cannot choose h4 anymore, right? So you cannot choose h4 anymore. So your number of buildings is now 1, right? So your number of buildings is not maximum. So the following configuration is not okay or not acceptable. So like there is only one configuration in case of n equal to odd, right? So if you have n equal to odd, there is only one configuration. That is, you just have to choose the alternate building starting from h2. You will have to choose h4, h6, and so on. So even if you take a bigger example, let's say for height 7, for n7, h2, h3, h4, h5, h6, h7. Here you have to choose 3 buildings. So the only configuration that you can have here is you have to choose h2, h4 and h6, right? There is not any other configuration. So now if there is only one configuration, like you can easily find the height that you want to add. So you can just iterate over all the buildings. So for I equal to 2 up to n, right? You can do I plus equal to 2. So like you can iterate over the gaps of 2 and find the height that you need to add for each building, and find height needed for hi, right? So that will be the logic that you can use for n equal to odd, right? So that's why I broke this into 2 subpaths, because if you want to solve this for n equal to odd, the solution is simple enough, and the solution is a little bit tricky when n is equal to even, right? So let's move on to the second subpart now. Also, the formula that you can use to find height needed for hi is, if you want to find the height that is needed for hi, the formula for that will be formula to find needed height for hi. It will just be how much? Maximum of 0, because the height needed will never be negative. So it will just be maximum of 0 and maximum of its left neighbor, right neighbor's difference with it, and one extra to make it taller, right? So that will be the formula that will be used to find the height needed for hi, right? So you can easily find this formula, right? It's nothing that tough. So now we have talked about case where n is equal to odd. So let's move on to the case where n is equal to even. So now the case where subpart 2 and n is equal to even. So let's take an example for this also. First of all, we will again find maximum tall buildings that we can have, and then we will talk about the minimum amount of moves that we need, right? So first let's try to find the maximum tall buildings that we can have. So let's take the example for, let's say, n equal to 6. So we have h1, h2, h3, h4, h5 and h6. So again, we cannot have h1, we cannot have h6, we can have h2, right? We cannot have h3, we can have h4, we cannot have h5 again, right? So if your n is 6, we have 2 maximum tall buildings. So for n, you will have n by 2 minus 1 tall buildings. You will have n by 2 minus 1 tall buildings. We can take some more example to show this. Let's say we take n equal to 8. So we have h1, h2, h3, h4, h5, h6, h7, right? In this also we can choose h2, we can choose h4, and we can choose h6, right? So here again we can choose n by 2 minus 1 tall buildings. So for a given even n, the maximum amount of tall buildings that you can have is n by 2 minus 1. So now that we know the maximum amount of buildings, now we want to find the minimum amount of moves that are required for that. So now we want to find minimum amount of moves required for n by 2 minus 1 tall buildings. But as you saw in the n equal to odd case, there was only one configuration. But in the following case, there can be more than one configurations. How can you see that? Like for n equal to 6, how many configurations can be there? So let's do this for n equal to 8, so you can see the pattern clearly. So for n equal to 8, how many configurations can be there? There can be h1, h2, h3, h4, h5, h6, h7, h8. We can choose h2, we can choose h4, we can choose h6, right? That's one. h1, h2, h3, h4, h5, h6, h7, h8. We can choose h2, we can choose h4, and then we can choose h7. Another configuration can be h4, h5, h6, h7, h8. We can choose h2, we can choose h5, and then we can choose h7. And another configuration can be we can choose h3, we can choose h5, and we can choose h7. So these are the configurations that we have, right? So now we want to find the configuration that will give us the minimum amount of moves. So now we want to iterate over these configurations and find the minimum amount of moves. But like there can be many configurations, right? There can be O of n configurations. There can be O of n configurations, and there can be O of n configurations. And if you try to iterate over every configuration, it will take O of n time. So in total, you will get O of n square time complexity. So it is not viable, right? So we have to do something to optimize this complexity. If you can observe a pattern here, there is a 2-element block in each of these, right? There is a 2-element block in each of these. So if you see this, here is a 2-element block, right? H7 and H8 is a 2-element block here. Similarly, if you see in the second configuration, H5 and H6 is a 2-configuration block. So sorry, it is a 2-element block, right? Similarly, if you check here H3 and H4 is a 2-element block. And similarly here, H1 and H2 is a 2-element block, right? And if you can observe the pattern, on the left side of the block, we are only using even index tall buildings. If you see, on the left side of the block, we are only using even index, right? We are using H2, we are using H4. These are even indexed. And if you see on the right side, we are only using how much? We are only using odd index buildings, right? Similarly, if you see in the third configuration, we are using even index buildings on the left side, and we are using odd index buildings on the right side, right? So you can find a prefix sum, right, for even index buildings, and you can find a suffix sum for odd index buildings, and you can iterate over this block and use the prefix and suffix sum to optimally find the answer for every configuration, right? So the solution is, we know there is a 2-index block, right? We know there's a 2-index block, and on its left side we are only using even index buildings. So we can use a prefix sum that will find the height needed for all even index buildings, right? We can use a prefix sum for this. And on the right side of this block, we are only using odd index buildings. So we can use a suffix sum to find the sum of these odd index buildings. And then we can just move our this 2-element block from right to left and find the answer. So that will be the solution to the problem. And if you can observe one more thing, that your 2-element block is moving 2 indices every time, right? So first it was on H7, H8, now it is on H5, H6, and H3, H4, and so on, right? So you can just iterate over all positions and keep incrementing 2 positions every time to iterate over all positions of your 2-element block. So if you want to see some kind of pseudocode for this, pseudocode will be, first I will iterate over all positions. Of the 2-element block. Right? So that will be something like, for I equal to 1 goes to n, we can increment 2 every time because our 2-element block is moving 2 indices every time, right? So it will be how much? I plus equal to 2. And then your answer will be how much? We know that this index is I, this is I plus 1. So your answer will be just be prefix sum over I and suffix sum over I plus 1, right? So your answer will be just how much? Answer is equal to minimum of answer and prefix of I plus suffix of I plus 1. And how do you find this prefix and suffix sum? It is also very easy. These are just sums of prefix of I is just sum of even elements up to I, and suffix of I plus 1 is just sum of odd elements up to I minus 1 from n, right? So this is just sum of even elements up to I, even indexed elements you can say, right? And this is sum of just odd indexed elements up to I plus 1. So that will be the solution. And if you guys want to see the code for this, here's the code. Here, if my n is odd, then there is only one configuration, so I can just do a brute force and find the answer for that configuration. Else I can find my prefix and suffix sum. Here I am iterating over from 1 to n and finding the prefix sum, and here I'm iterating from n minus 2 up to 0 and finding my suffix sum. Then for every block starting from I equal to 0 up to n, I am iterating over all the 2 element blocks here, right? From I equal to 0 up to n, I will add 2 every time, and answer will be just how much? Answer will be minimum of answer and prefix of I plus suffix of I plus 1. So I hope you guys are able to understand the solution, and if you guys have a doubt, do let me know in the comments and I will be happy to help you out. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.